Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Okay, now we want to talk about the continuous time signals based on complex exponential function. Okay, before we talk about the complex exponential function, let me discuss first about the real exponential function. Now, with the real exponential function, normally we have example of xt equals to a exponent minus t. Okay, so the function, okay, is based on the a exponent minus t, which we call as real, where you can see that the graph can be sketched something like this, okay, with the a when the t equals to 0. So this is for the real exponential function. But when we talk about the complex exponential function, okay, for example, say we have xt equals to a e negative jt. Okay, so you can see there is an imaginary number of j in this function, right? So how do we actually represent this function? Can we just sketch it on the graph? Okay, so actually there is a relationship between this complex exponential function with the sinusoidal function. Okay, so how are we going to relate them? First, if you can recall about the Euler formula, when we have any value of r exponent j alpha, for example, we can write it as r cos alpha plus j r sine alpha, right? Or if we have r exponent negative j alpha, we can write it as r cos alpha minus j r sine alpha. Okay, because the r cos negative alpha before this becomes r cos alpha. Okay, so based on this, if I rewrite this function based on this Euler formula, I can write it as a, put this parenthesis, we have cos j t minus, cos t. Okay, we have cos t, not cos jt. We just take the the constant of this t. So we have cos t minus j sine t. Okay, and when we open this factor, we have a cos t minus a j sine t. So what can we see the relationship between this complex exponential function with the sinusoidal? We can see that the cosine function, which is the sinusoidal function, is actually the real part of this exponential complex exponential function, and we also have the sine t here, which is the imaginary part, okay, of the complex exponential function, right? So only after we separate the real part and the imaginary part of these functions, then we can sketch the graph of this complex exponential function based on its real part and also based on its imaginary part.